third vlog on electrolysis. And this video we're going to look at the electrolysis of ionic compounds in solution. Now that introduces a whole new addition to the complexity of the situation, because of course if you're in solution you have water present. Now what's the problem there, Miss McLaren?
Well, water is very unusual because water ionizes, i.e. it produces a very small amount of ions, and it breaks up into hydrogen ions and hydroxide ions. And because electrolysis of ionic compounds involves ions, we need to take these two ions into consideration. Okay, so for example, if we had sodium chloride solution, we wouldn't only have the ions from the sodium and the chloride, we'd have hydrogen ions and hydroxide ions. That's correct.
So what would we have all together?
Well, guess what? The magic board.
Magic board.
So sodium chloride solution would have Na plus sodium ions, chloride ions, hydrogen ions and hydroxide ions from the water as well. So
Fabulous.
We're talking 4 ions involved in the solution, and 2 of those are going to go to one electron, the other 2 are going to go to the other electron.
So, if I'm not mistaken, the sodium and the hydrogen ions would both be attracted to the negative electrode.
That's correct, and they're called cations.
And the chloride and the hydroxide ion, OH minus, they would both be attracted to the positive electrode.
Which means they must be anions.
Okay, so what about if we had copper sulfate solution?
So copper sulfate solution, again, we have the aqueous there. So you're dealing with water, and that will produce your hydrogen ions and your hydroxide. And from your copper 2 sulfate, you get copper 2 plus ions and sulfate ions.
So again, we'll have the copper 2 plus and the hydrogen ions going to the negative electrode, attracted to the negative electrode, and the sulfate, SO4 2 minus, and the hydroxide, OH minus,
which will be attracted
to the positive
anode
electrode.
And they're otherwise known as anions.
Okay, now the last one, sulfuric acid. So that's in solution, that's sulfuric acid with water.
Now, sulfuric acid is ionic, and sulfuric acid contains hydrogen ions and sulfate ions. Now, because it's in solution, it will always have a small amount of hydrogen ions from water as well as the hydroxide. But you can see you don't really need to write the hydrogen ions twice, even though it's got 2 hydrogen ions in the formula. You would just say H plus, SO4 2 minus, and OH minus.
Now, if I'm not mistaken, Miss McLaren, it gets a bit complicated at the electrode to work out what is going to gain or lose electrons. So should we do that in another video?
Yes, I think what actually happens, if I give you an example, you'll have the 2 positive ions go to the cathode, 2 negative ions go into the anode, but one of those ions will only accept the electron. Basically, it's favoured. And then with your negative ions, only one of them will lose electrons, and we're actually going to give you all those answers in the next electrolysis.
It's a cliffhanger, in fact.
It's a cliffhanger. In fact, I find it quite electrifying.